This video will talk you through how to answer the RSFC F322 formal test on basic concepts and alkanes. Question 1. Now question 1 asks you a series of questions which are all based upon the 6 alkanes which are shown here. So the first things it asks you is which of these molecules doesn't fit the general alkane formula. Now the general alkane formula is CnH2n plus 2, and molecules A, B, C, D and E all fit that general formula. If you added up the number of carbons and the number of hydrogens, it would fit in with this. That's because they're all straight chain or branched alkanes. Molecule F, however, is a cycloalkane, and cycloalkanes have the same general formula as an alkene, which is CnH2n. As you can see here, 1, 2, 3, 4, 5, 6 carbons, 12 hydrogens, which fits in with CnH2n. Therefore, your answer will be molecule F, which doesn't fit with the general formula of CnH2n plus 2. Part B states that molecules A, B and C are successive members of the alkane homologous series, and then asks you what's the molecular formula of the next member of the series. So as you can see, molecule A has 1, 2, 3 carbons, and this molecule is propane. Molecule B has 1, 2, 3, 4 carbons, so it's butane. Molecule C has 1, 2, 3, 4, 5 carbons, so it's pentane. So the next member in the series will have 6 carbons, so it will be hexane, and it will have the molecular formula C6H14. Remembering that the general formula is CnH2n plus 2. You're then asked, what is the empirical formula of molecule F? Now, F, being cyclohexane, has the molecular formula of C6H12. Now, remember the empirical formula is the simplest whole number ratio of atoms of each element present in a compound. So we're looking for the simplest whole number ratio between the number of carbons and the number of hydrogens. We can divide each of these by 6, which will give us CH2. So the empirical formula of F is simply CH2. You then have to identify which 3 of these molecules are structural isomers of each other. Now, structural isomers are compounds which have the same molecular formula but a different structural formula, so the atoms are arranged differently in space. So you've got to find which 3 of these 6 molecules have the same molecular formula, but the atoms are arranged differently. So molecule A has the molecular formula C3H8. Remember, it's CnH2n plus 2. B is C4H10. Molecule C is C5H12. Oops, H12 should be. Now compound D, 1, 2, 3, 4, 5 carbons. So again, it's C5H12. Even though it's no longer a straight chain molecule, it now has a methyl branch. Molecule E, 1, 2, 3, 4, 5 carbons. So again, is C5H12. And molecule F, as we've said, is C6H12. So from that now we can see that the 3 molecules with the same molecular formulas are C, D and E, and these all have atoms that are arranged differently. So the 3 structural isomers are molecules C, D and E. And lastly, for question 1, you have to name molecules D, E and F. So molecule D as you can see, there's the longest chain of 1, 2, 3, 4 carbons, so that we know if the longest chain is 4, it's going to be butane. You can also see here that there's a methyl group attached, so it's going to be, the name's going to be methyl butane. We don't need to number which carbon this methyl group is attached to for butane, because if it was attached to this carbon, we would number it from the other side and it would also be attached to the second carbon. And if it was on either of the ends, the longest chain would now be 5 carbons. So the name for D is simply methyl butane. Molecule E has the longest chain of 1, 2, 3 carbons. So we know that it's going to include propane in the name. It now has 2 methyl groups attached. And again, we don't need to number which carbon these groups are attached to, because there's no other places that it could go. So this 2 methyl groups will be dimethyl propane, remembering that di means we've got 2 of the same group. So molecule E will be named dimethyl propane. Molecule F, now it's a cyclic alkane, and we know that for a cyclic compound we add the prefix cyclo. It's got 1, 2, 3, 4, 5, 6 carbons in the ring. We know 6, we would use the stem hex, so molecule F will be called cyclohexane. Now there's no other substituents, so we don't need to add anything onto the start of this, so the name will simply be cyclohexane. And that's question 1. Question 2. Now, to get most of the marks on this question, there's very little actual application of knowledge. So as long as you know your definitions and that you can recognise and identify the different functional groups that we've taught you, you should be able to pick up most of the marks quite easily for this question. So the first thing it asks you to do is to draw the displayed formula of 2-methylpentane. Remember that displayed formula shows every single atom and every single bond between the atoms. So it's basically drawing the molecule out in full. So pent tells us that the longest carbon chain is 5 carbons, and the ane tells us that it's a simple alkane with no double bonds. So we know we can draw the longest carbon chain in of 1, 2, 3, 4, 5 carbons. This 2-methyl tells us that on the second carbon, so 1, 2, we've got a methyl group attached. So we can draw that in, methyl group being CH3. And then we can fill in the rest of the hydrogens. Now it's worth mentioning that when you're drawing the methyl group, if you shorten it and just simply write CH3, this would lose you the mark for this question, because it's got to be the displayed formula, so it's got to show every single bond between the carbon and hydrogens, so you have to draw every little part out in full. The second question asks you to define the term structural isomerism. Now, structural isomers are compounds which have the same molecular formula but a different arrangement of atoms in space. So that is simply all you have to write for the definition. you can either write with a different arrangement of atoms in space or with a different structural formula. Either one would get you the mark. Part C then asks you to define the term functional group. And a functional group is the part of the molecule which is responsible for its chemical reactions. So again, simple definition, if you learn it, functional group is the part of the molecule that is responsible for its chemical reactions. Last part of this question then asks you to name the functional groups shown below. The first one shows we've got a carbonyl bond here attached to a hydrogen, and you should recognise that that is the functional group of an aldehyde. So this functional group is an aldehyde. COOH you should recognise as being a carboxylic acid, and if we were to draw it out in displayed format like this, we would have a carbonyl bond attached to an OH group, and again this is a carboxylic acid functional group, so your answer would be carboxylic acid. Question 3. So question 3 is all to do with isomerism. The first two parts are to do with structural isomerism, which, as if you remember from the definition, are compounds that have the same molecular formula but a different structural formula. So firstly, you've got to draw the skeletal structure of pent-2-ene. So the skeletal structure just shows us the carbon chain. Pent-2-ene tells us that the longest carbon chain is 5 carbons, and it has a double bond between the second and third carbon. So the skeletal structure will look like this. You then have to draw one structural isomer of pent-2-ene. Now there's different options. The simplest one would be pent-1-ene, where the double bond is in a different place, attached between the first and second carbons, which would be as follows. There's also several branched versions that you could have drawn, which would have got you the mark. For example, 2-methyl-but-1-ene. And there are various others. All you have to remember is they have to have the same molecular formula, but a different structural formula. Part C then asks you about EZ isomers. EZ isomerism is a form of stereoisomerism rather than structural isomerism. So the important part is this carbon-carbon double bond. Now, when you're answering a question and you have to draw EZ isomers, I would always start with the carbon-carbon double bond. Now it says here, I want you to draw the isomers of pent-2-ene. So remember, it's this molecule here that we've already drawn. If we look where the double bond is, we've got a methyl group on one side, so we can add that in. And on the other side, we've got an ethyl group, so we can draw that on. Now, depending on which side of the double bond I put this ethyl group will depend on whether it's an E or a Z isomer. Now, I'm not going to explain exactly what those are yet, because that comes in the next question. So if the ethyl group goes on this side, C2H5, we can then fill in the hydrogens. So the two priority groups, which are the methyl and the ethyl, are on opposite sides of the double bond. This therefore will be the E isomer. The other possible isomer, again, if we draw in the double bond, there's the methyl group, the hydrogen. So if we draw if the ethyl group is on the same side as the methyl, as you can see here, this would be the Z isomer. And the way to remember that is in a German accent, Z is the same side. Which a lot of people laugh at me for saying that, but never mind, it helps me remember it. So the next part of the question asks you to explain how this type of isomerism arises. And as you can see, this question is worth 2 marks. So the 2 marks will come from the first point will be by saying that it must contain a carbon-carbon double bond because this restricts rotation of the bond. So this type of isomerism arises when there is a carbon-carbon double bond which restricts rotation of the molecule. So just by saying that would be your first mark. The second mark then, the other key thing that you need for having stereoisomers is that there's got to be 2 different groups on each carbon of the carbon-carbon double bond. So if we follow on from that and say, so when there is a carbon-carbon double bond which restricts rotation of the molecule and different groups attached to each carbon of the double bond. So that bit is key. They've got to be different groups attached to each carbon of the double bond, and that will be your second mark. Last part then, it says pent-2-ene also exhibits cis-trans isomerism. Now cis-trans isomerism is a form of EZ isomerism, and on the molecules in part C, label which is cis and which is trans. Now at this level, E isomers are always going to be trans isomers. So E is the same as trans because the 2 priority groups are on opposite sides of the double bond. And the Z isomers will also be cis because the 2 priority groups are on the same sides, or the 2 non-hydrogen groups are on the same side of the double bond. Last part of question 3 asks you to calculate an atom economy. Atom economy tells you how much of the products formed is actually the product that we want. So you can see from this reaction, we've only got 1 product, which means that there's no unwanted byproducts or any waste products at all. So the atom economy will simply be 100% because all of the products formed is the desired product that we want. If you were working out this question and it gave you, say, 2 or 3 products, so we had to take into account the waste, the equation that you would use would be this. So it's the MR of the desired product divided by the MR of all the products. So this is where we take into account any other products formed. Times that by 100 so that it's a percentage. In this case, the MR of the desired product, if we add up 5 times 12 plus 11 plus 16 plus 1, the MR is 88. Now this is the only product we've got, so it would be 88 divided by 88, which is 1, times 100, which would give us 100%. It's always useful to show your working, even if you do only have 1 product, because it shows that you know what you're talking about. And it's also getting into good habits for if you've got a more difficult question. Question 4. So this question is all about combustion and boiling points of alkanes. So first thing, you're simply asked to explain what the term saturated means. Saturated means contains only single bonds, so that is all you need to write. And the ways to remember that is S for saturated, S for single. So it's saturated is single bonds. Unsaturated would mean it contains double bonds. So your answer would be contains single bonds only. You're then asked to write a balanced equation for the complete combustion of propane. And as you can see, this question is worth 2 marks. 1 mark is for identifying the correct products of combustion. And if you notice here, it says the complete combustion. Complete combustion occurs when there's a plentiful supply of oxygen and the products formed are carbon dioxide and water. Remember, it's the complete combustion of propane, which is C3H8. We burn it in oxygen, and so the products produced are CO2 plus H2O. That will get you 1 mark. The second mark then comes from balancing the equation. So as you can see, we've got 3 carbons here, so we're going to need 3 in front of the CO2. We've got 8 hydrogens here, so we're going to need 4 waters. And now we've got 4 oxygens plus 6 here, which is 10. So we're going to need 5 O2. The correct balancing will get you the 2nd mark for that question. Part C then states that the boiling point of propane is lower than that of octane, and you've got to explain this clearly. So again, it's a 2 mark question. First mark is for stating that the propane is a shorter chain alkane than octane. Because it's shorter, that means that there's less points of contact between the molecules. So there's less van der Waals forces, or weaker van der Waals forces between them. So your 2nd mark would be for saying there's less or weaker van der Waals forces between the molecules. Part D then, you have to draw 2,2-dimethylhexane. Now this question doesn't specify whether it wants a structural, a skeletal or a displayed formula, so you would get the mark for the correct structure however you drew it. I would always go for skeletal because it will save you time. So hexane, we know the longest chain is 6 carbons, so we've got, oops, dodgy pen, 1, 2, 3, 4, 5, 6 carbons. Dimethyl means that we've got 2 methyl groups and they are both attached to the 2nd carbon. So we would show that like so. Part E then asks you, would you expect the boiling point of octane to be lower or higher than the boiling point of 2,2-dimethylhexane? And obviously to explain your answer, and it's worth 3 marks. Now octane and 2,2-dimethylhexane are structural isomers of each other, which means they've got the same molecular formula but a different arrangement of atoms. The difference is that octane is a straight chain molecule with the longest carbon chain of 8 carbons, whereas 2,2-dimethylhexane, as you can see, is a branched molecule. Now because it's a branched molecule, there's less points of contact between the molecules, so there'll be less or weaker van der Waals forces between them. And it's the van der Waals forces that must be overcome when we're moving the molecules apart and boiling them. So the 3 marks, firstly, you would get 1 mark for stating that the boiling point of octane is going to be higher than 2,2-dimethylhexane. So simply stating the word higher would get you the first mark. The second 2 marks are then therefore for giving you reasons, similar to part C. So by saying that 2,2-dimethylhexane is branched, so 2,2-dimethylhexane is branched, therefore there's less points of contact between molecules. That would be enough to get you the second mark. And the third mark would be for saying, so weaker or less van der Waals forces between molecules. So obviously it would take less energy to overcome them. As you can see, for these 2 3-mark questions, you don't need to be writing absolutely loads. As long as you bullet point your answers and you've given enough bullet points to get you the 3 marks, you don't have to write a lot at all. Question 5. This is an 8-mark question, all about the use of alkanes in fuels. So as you can see, it says here, the first stage in the production of petrol in the oil refinery is to fractionate the crude oil. So that's a reference to fractional distillation. It then says, after that, refineries carry out further processes. Outline with the aid of equations 3 of these processes in the production of petrol, and explain why the products of these processes are often added to petrol. So it's not asking you to give details about fractional distillation, as it mentions that in the question. It's asking you about the processes which are used after fractional distillation. And like I said, there's 8 marks available for this. The first mark comes from simply identifying what these 3 processes are, which are cracking, reforming and isomerization. So that will get you 1 mark. You then get a mark each for giving a definition or a bit of a summary about what each of these processes does. So cracking, this converts long chain alkanes into shorter chain alkanes, and you also get an alkene produced as well. So that will get you a mark. Stating that isomerization converts straight chain or unbranched hydrocarbons into branched alkanes will be your 3rd mark. And reforming, this is the process that converts straight chain hydrocarbons into cyclic or aromatic hydrocarbons, and this is done by removing hydrogen. So up to now, we've got 1 mark for identifying the 3 processes, and we've got 1 mark each for giving the definitions of each process. So there's still another 4 marks available. As you can see in the question, it says outline with the aid of equations. So that means that we've got to give an equation for each process. So I'll just give an example. Cracking, which we've said converts long chain alkanes into shorter chain alkanes and alkenes. So an example of this would be, for example, decane, C10H22, would be cracked to give ethene, C2H4, plus octane, which is C8H18. So given an example with an equation, again, that would get us another mark. Isomerization converts unbranched hydrocarbons into branched alkanes. And again, it doesn't matter whether you use molecular, structural, skeletal, or displayed formula because it's not specified in the question. So as long as you've given an equation and the molecule's right, you should get the mark. So for example, here I've used skeletal formula. So we've got octane, 1, 2, 3, 4, 5, 6, 7, 8. Would undergo isomerization to give a branched isomer. And again, you could give any example for this as long as you've shown that you've converted an unbranched hydrocarbon into a branched alkane. And as you can see, 1, 2, 3, 4, 5, 6, 7, 8. 1, 2, 3, 4, 5, 6, 7, 8. We've not lost any carbons. Reforming then, converting an unbranched hydrocarbon into a cyclic compound. For example, pentane could be converted into cyclopentane. And to do that, we've had to remove a hydrogen molecule. We then get another, so there's another mark available for each of those. So up to now, we've got 1, 2, 3, 4, 5, 6, 7 marks out of the 8. The last part of the question then, it says explain why the products of these processes are often added to petrol. So your last mark will be for explaining why we add the products of cracking, isomerization and reforming to petrol. And that is simply because it promotes more efficient combustion. So the products of all of these processes all have shorter or branched or cyclic molecules which have a lower boiling point than the longer chains. Lower boiling points means that they will combust more easily. So that's why they're added to petrol. Simply for stating that they promote more efficient combustion will get you the 8th mark. Question 6. As you can see, this is a big 13-mark question, all to do with isomerism. Now, don't assume that just because it's a 13-mark question that you've got to write loads and loads. A lot of the marks are available for giving examples, so just by drawing molecules of the different isomers. So firstly, it says explain what is meant by the terms structural isomerism and EZ isomerism. So marks are available just for giving definitions of each type of isomerism. So firstly, as we've said earlier, structural isomers are molecules with the same molecular formula but with different structural formula. So 1 mark is available for stating that. EZ isomers, we get when there's a carbon-carbon double bond. It's a type of stereoisomerism, and each carbon of the double bond must have different groups attached. So there's 2 marks available for this definition. 1 mark is for saying that we must have a carbon-carbon double bond, and the second mark is that we must have different groups attached to each carbon in this double bond. The rest of the marks then come from giving examples. And as you can see in the question, it says, in your answer, refer to the isomers of C5H10 only. So all the examples we give must have the molecular formula C5H10. So for structural isomers, one isomer of C5H10 is simply pent-1-ene. So we would get 1 mark for drawing this, and another mark for naming it. Another isomer would be pent-2-ene, so with the double bond attached to the second carbon instead of the first. So again, we would get 1 mark for drawing the molecule. And the second mark would be for naming it. We could also use branched isomers, for example, this molecule here. So again, a mark for drawing it, and the second mark will be for naming it. Now, as you can see, the longest carbon chain is 1, 2, 3, 4. So it's butene. The double bond is on the first carbon, so it would be but-1-ene. And there's a methyl group attached to the second carbon, so it would be 2-methyl but-1-ene. And as you can see, all of these isomers are structural isomers of C5H10. For the examples of the EZ isomerism, we can use pent-2-ene because, as you can see, it's got a carbon-carbon double bond, and also each carbon of the double bond has different groups attached. So this carbon here has a methyl and a hydrogen group attached, and this carbon has an ethyl group and a hydrogen attached. So if we start by drawing the carbon-carbon double bond, as I said, 1 carbon has a methyl group attached and a hydrogen. The other carbon has an ethyl group. So this isomer, as the 2 priority groups are on different sides of the molecule, this would be the E isomer. The Z isomer then, both of these 2 groups will be on the same side of the molecule. So Z, both substituents are on different side, are on the same side, sorry. So for the 13 marks for this question, we've got 1 mark for the definition of a structural isomer. 2 marks are available for the definition of EZ isomerism. We then get 1 mark for each of the 3 examples of structural isomers. If you gave more, that's fine. You wouldn't lose any marks, but you just wouldn't gain any extra marks, because obviously there are more isomers that you could have drawn. We then get a mark each for naming the isomers, so pent-1-ene, pent-2-ene, and 2-methylbutanene. We then get a mark each for drawing the E and Z isomers, and we get a mark for labelling them as E and Z. So all in all, that's 13 marks. And that concludes the F322 formal assessment on basic concepts and alkanes.